So I'll hit the play button. Yeah, so I'm Michael. I work at HashiCorp. I've been here for a few years now. And since this is a truly global conference, it actually follows the sun. It's 24/7. I thought it would be nice to take a moment to tell you where I'm coming to you from. So I live at the confluence of the Columbia and the Willamette Rivers, the original homelands of the Multnomah, Clackamas, Clackamas, bands of Chinook, Tualatin, the Kalapuya, Northern Malaya, Malola, and many other tribes that used to call this home, or still do call this home rather. But today we more commonly refer to this area as Portland, Oregon. And as Taylor alluded to, this is what the map looked like over the last few days because we had a pretty intense ice storm. This is the outage map from my local power company. And as you can see, a lot of the state was out of power. So even though they worked around the clock, I was still without power for a few days, trying to make do with this analog setup to prepare for the talk as best I could. It wasn't until yesterday that I was able to really get together and make proper slides. So please forgive me if this is a little rough around the edges. But you probably know me from my contributions on Nomad. So for the last 4 years almost, I've been at HashiCorp working on Nomad UI the entire time. I wrote the first lines of code and I kind of watched it grow and helped it grow into the mature web-based interface it is now for interacting with Nomad clusters of all scales. But practically speaking, what this means is that I am a JavaScript developer and I write JavaScript for the browser. JavaScript is a high-level language. It's got the loosest types imaginable with judicious type coercion. There's no memory management. It's got a garbage collector. It'll be fine. Since it's in the browser, there isn't a file system either. Everything's going to be through APIs. So it's not even an exaggeration to say that at this level that I'm an engineer at, computers are an implementation detail. Which brings us to the title of this talk. I just want to ship my code, Waypoint, Nomad, and other things. I want to start by talking about these two tools that are really popular among my cohort of engineers, Netlify and Vercel. These are both kind of known as static website hosting, but they're both pushing into this sort of serverless space. But the core developer experience here is that you push your code to your repo and you receive a website. It's really that simple. They have like a web-based configuration or a configuration file that sits in your repo, but really it's just like, it's a Git hook and you get a website. It's awesome. But you wouldn't be at a HashiCorp conference if you weren't interested in the ops side at least a little bit. So you might be puzzled by this, sort of like, yeah, that's great and all, but like, how does it do it? Like, what's going on inside there? Short answer is it's just none of your business. It just isn't, right? Like whatever magic they're doing, that's their business. But we can think about it a little bit, right? We know there's going to be some sort of data plane, which is going to be their customer sites or your or my site, as it were. There's going to be some sort of control plane that's controlling all this behind the scenes, which implies some sort of scheduler to make sure everything's running smoothly. There's going to be lots of DNS for all the static files. They both talk about a CDN, so there's got to be some sort of server-to-server file propagation going on. I mean, maybe they're using CGI then, who knows really? But I think it is safe to say that there are a bunch of engineers of all sorts of skill sets working on this to make sure that everything goes smoothly and that you don't have to think about it. So, and that's awesome, right? I don't want to have to think about this, and they do want to have to think about it. So that's perfect. It's a great system, and it's just sort of business, as you could tell by the screenshot of the most clippest of art, including the watermark. This is their business model. They accounted for this. They wouldn't be in business if they didn't think through the financials and say, yep, we can do this as a service and be profitable and sustainable. And we trust them, otherwise we wouldn't use their service, right? So that's wonderful. What happens when you host your own internal platform? I remember back pretty early in my career when I worked at a place that was on-prem and we were using kind of stale technologies. And I'm looking around and thinking, why aren't we using more Python? Why aren't we using Ruby? Node.js came out. It seems to be pretty awesome. Why aren't we using that? And when thinking about introducing changes to a system, I can't help but think about power dams. So when you introduce a dam in a river, there's no way you can do that without impacting the river itself. There are literal upstream and downstream effects. So it's great to think about when you're thinking about systems. Upstream, you're going to get flooding. You just are. And that can impact communities that are along the shoreline. So that needs to be considered. And then downstream, there are going to be ecological impacts, largely fishing as well. So you have to think about these things when you're introducing the dam. If you don't, it's still happening, whether or not you think about it as something that's outside of your control. So ideally, you are getting participation from everyone who's using the river before you pursue a project like this. And when you don't, bad things happen. So this is an extreme example of sort of what ends up happening when you don't consider the full system and you leave large parts as sort of externalities, not part of your model. So on the left here is a screenshot of Hummingbot, which is a automatic crypto trading bot. And if you're a crypto trader, this seems great. You run it, it's just a container, run that in your home lab, and now you're making money with your money by doing automatic transfer trades. Except the thing is, those crypto trades require proof of work that needs to be computed on the blockchain. As the blockchain is super volatile, that all requires power, which means you get crypto miners who are trying to make money just off of that. Those crypto miners are constantly looking for places that are the lowest possible or price for power. And they also come and go as Bitcoin price goes up and down, which creates huge volatility in the areas in which they want to set up camp. And some of those places end up actually being the Columbia River Basin because we have so much hydroelectric power, and ends up being really cheap normally until you end up with a surge of Bitcoin miners. So from the left, if you're a crypto trader, this looks awesome, fully automated, set it and forget it. But if you're a utility worker in Eastern Washington, this is horrible. It is far from automated, trying to calculate into your model what's actually going to happen when crypto prices go up and down. So takeaway here is you need to consider the whole system if you're going to own the whole system. This is a capture from our co-marketing with GitHub for the cloud operating model, and I think I really like it, especially the shape to sort of this continuum of developing, testing, deploying, provisioning, securing, connecting, and running. You need to make sure that everything is considered when you're architecting. And we try to be ops friendly at HashiCorp. All of our tools are kind of built for running on your own. Granted, we have HCP, so you don't have to do all of it yourself now, but still we want to make sure that it's always comfortable. So Nomad, right on the sticker, it says that it's operationally simple, and Kubernetes is sort of like the de facto standard for run your own scheduler. And you can see from all these screenshots from our Learn site, from our blog posts, from our registry, we try really hard to make sure all of our software works well within the Kubernetes ecosystem. But it is possible to go too far this other direction. If you make things too comfortable it's possible to make things too comfortable for this sort of infrastructure group side of the house at the expense of the app development side of the house. So maybe you've also worked at places where the infrastructure group has really locked things down. So you're tied to certain versions or certain frameworks. They say no to whenever you want to try something new. And that's no good either. That's an unhealthy ecosystem, and where you're treating the app developers as this sort of externality. So HashiCorp has a newer solution for that too. This is where Waypoint comes in. So if you want that Heroku-like experience, but you have your own internal platform, we're trying to answer for that as well. We want to create a consistent dev-friendly workflow that's decoupled from platforms. With Waypoint, you get a single configuration file. This should look familiar if you've used Terraform, or if you've used Nomad, or if you've used newer flavors of Packer. It's HCL, you kind of know it and you love it. And we're going to dig into this with our first demo, where we're going to deploy a simple Node.js website onto Kubernetes. So as I mentioned, this is decoupled from the platform. So Waypoint itself has to run somewhere. I already have it running here in my local Kubernetes cluster, which is running through Docker on desktop. So we can see the Waypoint server as a stateful set, it's running. First thing I want to do is make sure the correct browser has focus so it opens the right place. And then I'm going to run a Waypoint UI-authenticate. This is going to open up my local Waypoint server. Uses TLS, but it's not signed because it's all local. So here's Waypoint. This is the UI. Again, there's no tricks up my sleeve or anything here. This is, you can clearly see it is running in my local Kubernetes cluster. So now that it exists, let's initialize a project. So I'm going to run a Waypoint init because I happen to have a Waypoint file where I am. Now if we come over here, we see we have this project. And we've seen this in other talks already, but in case you haven't caught those, it really shows the model pretty clearly. You go from builds to deployments to releases, and you can see logs as they go. So I'm going to build this first thing first, just because it can take a while. So you run Waypoint up, and that's going to build in the background. It can take a little while, and everyone knows that computers work faster under pressure. So I'm going to start this timer here to make sure it's going as fast as possible. While that's going though, let's look at this Waypoint configuration file. First, we're declaring our app, example Node.js. We have some labels for sort of metadata on the Kubernetes itself. We have this build step, which is kind of a big one. We're using pack, as in build packs, with no additional configuration. So it's going to effectively look at our source code, determine what is the best environment to build a container for, and it's going to do that. Then we go into the registry, where we're going to upload the artifact that gets created by pack into some registry. It happens to be local here. And then lastly, we deploy with Kubernetes, and then we release with Kubernetes. Pretty default options. All right. Thank you, stress timer. It worked. As you can see with Kubernetes or with Waypoint, you automatically get these URLs. So let's try opening one of these. Wow, we have a website. And this is running in our Kubernetes cluster. We can confirm that. We can go to our replica sets here, and we can see example Node.js. This is us. And we can look at it here, and everything's good. I believe this also comes through in networks. So you can see a pretty typical Kubernetes deployment here. All right, let's go back to slides. So hopefully you saw everything. I know it was kind of quick, but honestly, the more interesting part in my mind is the stuff that you didn't see because it just wasn't there. Even though we ended up with a Docker container, you didn't see a Docker file, you didn't see Docker compose. And even though we ended up with this replica set and a deployment and a service, you didn't see any of those things. We didn't make them. We didn't use kube control, even though somehow this was applied. And you didn't even see any YAML actually, but this is Kubernetes, so you know it was there somewhere. And this is the power of abstractions. So there's this kind of 4 phases that Waypoint tries to think about it. Registry is a little hidden, but we're going to talk about it today. So first, you start with your source code. We didn't look at it too closely, but you can imagine it's a Node.js project. There's a package.json file, there's some JavaScript, and there's some static files like templates and images. Then we're going to build this into some sort of artifact using build packs. That's going to give us this container image. That's going to get uploaded to any form of registry. That could be Docker Hub, it could be ECR, it could be GCR. And then we deploy it using a replica set and a service here. And then sort of behind the scenes, we run effectively kube control apply, and then we create a deployment object as well. So all this is happening. It's just happening under the hood. It's all abstracted. So if Waypoint is true to its word, then this should be decoupled to platforms. So let's actually try replatforming. Let's try moving our same Node.js service from Kubernetes onto Nomad. So this is what it looked like before. What we want it to look like after is this. We want to change the deploy and release phases to now use Nomad tools here. So everything up to the registries can be the same because Nomad also uses Docker containers. But now we want to create some form of job spec that gets run in the Nomad cluster, and then Nomad for service jobs have a built-in deployment notion. So that sort of is our release step. So this will be the Waypoint file for that. Looks very similar. Build, pack, registry, Docker, except now deploy as Nomad. Just to make this really easy, I have this kind of ghosted old version. So you can see it's a little shorter. That's just because there's less metadata kind of annotated in throughout. But effectively, it's the same, especially from the perspective as me as an app developer. This build step is basically the same in the deploy step. Although it's different, it's like the same number of lines. They just have to change some stuff. Not a big deal. So let's see if we can prove that this is a thing that actually happens. Demo 2. Let's go back here. And then I also already have Nomad running, but it's empty. Actually, the first thing I need to do, though, just to be sure that nothing happens, this isn't something you would have to do. This is something I have to do because I am running Waypoint on 2 platforms. Normally, you would not be doing this in rapid succession like I am. But let's just make sure that Waypoint is truly gone here, because it does not like being run on 2 platforms on the same machine at the same time. All right, so back to Nomad. Nothing here. We're going to move over into here. And we're going to see the step that you didn't see for Kubernetes. So when you want to run a Waypoint on a platform, you need to run a Waypoint install. You need to tell it what platform. So this time it's Nomad. And then you need to blindly accept the terms of service without reading them, because that's what you do. So you can see it's going to create an allocation. Everything's going to run. Boom. Looks like that. So it looks like it's running. In Nomad, we can see it's running also. So if you're used to Nomad, seeing a job, very normal. It's an allocation. We can go inside this task. We can look at its logs. This is clearly a thing that is running. Then we can use the exact same Waypoint UI authenticate command to open up the UI, but now it's on Nomad. So you can see that Waypoint itself is not a platform per se. It is a thing that runs on top of your platform that sort of acts as that convenient developer experience front door into whatever infrastructure you have underneath it. So now let's try to run that Waypoint config that I showed. We can actually look at the file this time. So you can see there's a package.json, there's some stuff in here. There's some other stuff going on, I don't know why, so I'm gonna pretend I didn't see that. And I'm gonna run Waypoint init. And then I'm gonna run Waypoint up. I'm gonna run term down. And then let's look at the UI here as well. So we can really see that the build is happening here. And it's going to continue throughout. At this point, you're not going to see anything in Nomad because this is happening on my local machine, right? This is being built. You can imagine this happening on your computer or in CI. In fact, we've seen earlier today, Waypoint doing this building step inside of GitLab. So it can run anywhere, wherever Waypoint is. In fact, it could potentially even build inside the Nomad cluster if that's where you wanted to build it, if you're also using Nomad as your CI tool. All right, as I said, it could take a little bit. It seems to be pretty cool under pressure. All right, there we go, done. Okay, so now that we have this, we can see that we have our example Node.js with this kind of identifier at the end, just like we saw in Kubernetes. It is also running. And we should be able to open this up and bam, you see it here as well. So there you go, replatformed onto Nomad. So the takeaways here that I think are important from the perspective of a product engineer is number one, there was no workflow change. A Waypoint file, Waypoint init, Waypoint up, that's it. There was also very little code change. You saw the before and after of these two Waypoint configuration files. Just not a lot changed. It was basically just annotations for the different platforms. And there are also minor conceptual changes to the output. Of course, we did replatform from Kubernetes to Nomad, and they are not the same thing. But since they both are orchestrators and they both rely on containers, a lot of the working model is similar. So even though you do have to go through different steps to say monitor an application, it isn't the same as completely changing everything. And that's because Kubernetes and Nomad are built on top of its common abstractions. So there's kind of a bigger thing at play as well. It's abstractions all the way down. Like I've been talking about this as Docker containers, but that's only halfway true. If you follow Kubernetes, then you know in version 1.20, Docker is actually deprecated with a blog post that starts with "Don't panic." So let's dig into that a little bit. How could Docker possibly be deprecated on Kubernetes? If you're like me, you kind of think of this evolution of tooling, right? Where we had containers, yes, but from containers stemmed this new world of orchestrators that relies on containers. We got Swarm, we got Mesos, we got Kubernetes, we got Nomad. So how could that be? It just seems like Kubernetes turned around and backstab Docker or something. That's not the case. We just need to look a little closer at what Docker is. So Docker is actually multiple things. There's this sort of client commands, Docker build, pull, run. You've probably used them if you use Docker. Then there's a host with the daemon, and this daemon is going to pull images down from a registry, and then from those images, create those containers which are actually run. So how do you get rid of Docker then inside of Kubernetes? You introduce a container runtime interface. Once again, we see the power of abstractions. So instead of using the Docker daemon to run these containers, you're going to use containerd or another sort of runtime interface, or runtime layer that implements this interface. So that way, you still use the same containers. In fact, you can still use Docker files and still use Docker build to create this open container format. You're just not using the Docker daemon on the clients of your Kubernetes cluster. And if you really want to go deep, you can actually kind of open up containerd and look at all the little bits and pieces inside of it to really see all the intricacies of what a container is. But I don't want to do that. I'm going to put a lid back on that. Honestly, I don't want to think about containers ever. Like, I kind of feel like I've lost the thread a bit because this whole talk was about just wanting to ship my code. And now I'm talking about containers, and that's kind of annoying. But the thing is, not only are containers apparently an implementation detail. The entirety of Docker is an implementation detail, which just begs the question, what else can be removed? And what will it take to do that? To answer that question, we first need to ask the question, why are we using containers? And not like the nuts and bolts stuff like we were just talking about, but the workflows here. Like, what is it that makes containers compelling to us as developers responsible for our software? And there's sort of these four common pillars. There's immutability, because we don't want drift. We just heard about drift in Terraform. It's not what you want. So immutability is great for that. You want portability, because you want to be able to run things on your machine as well as other machines. And you want to be able to think of these containers as quote unquote cattle. You also want isolation. You want to sort of be cloud native in the sense that you assume everything is multi-tenancy, and you assume that there are threat vectors everywhere, including other people who may even be at your company, even by accident. And you want resource limits as well. We're not in a world anymore where things get to just gobble up everything on a computer. You need to be able to restrict access, again, for that multi-tenancy. So let's look at how Nomad sort of handles the idea of running software in general. The task driver model for Nomad is loosely abstracted, it's unopinionated, and it's a pluggable runtime model. So these task drivers range from straight up running raw processes to virtual machines to containers. Many of these are built in, and many of them are also community owned, as you can see in this red box here. I particularly want to look at the Nomad exec driver right now. So what the exec driver does is going to build a change root, and it's going to build a control group for you. And it allows you to configure the resource limits of that control group, and it's going to do this all on demand on the client as it's requested. So that's pretty neat. Let's consider our four checkboxes here. We want all these things checked. Sounds like that gives us isolation, it gives us resource limits. That C group and the change root and those resource limitations, boom, that's two of them. How do we get immutability without containers though? Well, we make a binary. Binaries have been around since the beginning of computation, effectively. That's not true, but I'm going to say it. But we can do this with Node.js also. There's a tool by Vercel, which you may remember from the top of this talk, called Pkg. I don't think that you're going to see this on the CNCF landscape because this veers so heavily left of the spectrum towards app development land, but it's pretty neat. So it basically looks at your package.json file and your source codes and turns it into a single file that is an executable binary. And it can be built for different runtimes, or different architectures rather. If you use Node.js, you're thinking, hold on a second, I have static files in here. Like, what about the images? What about the templates? So you can actually annotate that in your package.json, as you can see here. You can give it sort of globs that it's going to incorporate. A little sidebar, Nomad UI is actually built in a very similar way. Of course, Nomad is Golang, it's not Node, but it also builds a binary by baking all of these UI assets into it. That gives us immutability. So the last box that needs to be checked here is portability. Well, once you have a binary, portability is actually super easy because file servers are as old as the dawn of time. They're tried and true, they've been around. You download a thing, you checksum it, and you're off for the races. So all four boxes checked. Let's put it all together. So before we were using build packs, which you could think of as a Docker file if you're not familiar with build packs. Now we're going to be using Pkg, which gives us a binary. Before we were using a container registry that we could download containers from or images from. Now we're going to be using a file server. In production, this is probably going to be S3 or some S3 compatible thing. Before we were using the Docker driver in Nomad. Now we're going to be using the exec driver. All right, third and final demo. Can we run the same Node.js package or same Node.js project on Nomad, this time using the exec driver and Pkg as the builder? Let's come back over here. Let's open up this. I also want to make sure that I stop this job. It's the old one. We want to run this new one. So last tab. First, I want to show you the changes to the package.json. So here we go at the end. There's package assets. It's just what we saw on the slide. I literally copy pasted it. So our views or our templates, public is where we get our images. That's that. And then I'm going to run Waypoint init since we already have the platform running. It's been initialized. Now we're going to run Waypoint up. You can see there, it's going to build. And that's the issue that I thought I fixed. Let me try hitting harder. Oh, come on. All right. I think we can work through this with more sledgehammering. Oh, come on, Zoom, go away. Please, Zoom. Okay, let's reinstall onto Nomad. Then let's run Waypoint and it again. Let's try running Waypoint up again. Why do you want to do this to me? All right, that's fine. You're just gonna have to pretend that actually worked. This is interesting. I had been having issues with the Kubernetes one, not this one. So I'm kind of at a loss for why it's choosing to do this now. Let's actually try one more thing. I think I've got a couple minutes to play with. Let's try really blowing away state. Sorry about this. Normally I'm pretty good at talking and doing things at the same time, but when things go sideways, you end up in this situation. Okay, let's see where we're at here. So we should have no jobs, good. Should have both clients, good. Let's go over here. Let's run this again. Good, good. And then waypoint and it, waypoint up. Okay, there we go. So there's something saucy going on in there, but it's running this time. Phew, that's a relief. So thing is, as I said, this is rough around the edges. Networking isn't working here, but we can still prove that this did work. So we have our job here. We can still go into its allocation. We can still go into its task. We can look at its driver, which is exec. We can look at its logs. It still shows. We can also kind of go back here and we can exec into this. And if we do that and we run this, we're inside of our container here. We can go into local. We can see that our binary did make it in, that Node.js. And we can also still curl locally our thing. So not as pretty as rendered HTML, but there is HTML, which proves that it did work. Okay, quickly now, back to slides. All right. So here we are before, and then this is where we're at after. So big thing is we've now changed the left side of the spectrum. We're now building using package, which gives us a binary. We upload that to a registry, which is just any old file server. And then it continues on, as it were, inside of HCL. But the big takeaway here is with Waypoint, there is no workflow change. We've gone from Kubernetes to Nomad. We've gone from Docker to a binary, and there's no workflow change. And that's kind of incredible. Maybe you're a skeptic and you're thinking this guy works for HashiCorp. He's just trying to sell us something. And you're right. I work on box software, right? Who am I to tell you about how to deploy software? But I think there's something valid here. So let's review some stats. When you're building a container, it's going to take somewhere between 30 and 60 seconds. And it's going to result in an artifact that is over a gigabyte. When you're building just a binary, under 5 seconds, and the artifact size is just 46 megs. Safety is totally not guaranteed here. This is not ready for production, but please do check out the code. This is a custom Waypoint plugin that I had to write, but that's also Waypoint's model, is that you can write plugins pretty quickly and then sort of drop that in wherever you're building, and then you get it as well. So the moral of the story here isn't for you to change everything to exec and use binaries and then complain when things are broken. It's to consider the whole system. It's to consider interfaces as well and how they help us work with our coworkers and collaborate. It's to look at abstractions because they're all around us, and it's also to challenge those abstractions from time to time. And if you are an engine manager or if you're a tech lead, it's also important for you to make time and space for that R&D. If you're not making time and space, it's not going to happen. And that's how you get tech debt. And tech debt's okay, but if you don't pay it down, then you get lots of tech debt, and that actually becomes a liability. So please do make space for this type of R&D. Thank you all for watching this talk. You can find me pretty much anywhere on the internet at Ding Fuss.